Welcome student back to this example where we need to calculate a triple integral where E is the region bounded by the surfaces x equal 4y squared plus 4z squared. Of course, this will give me a paraboloid in the 3 dimension, and x equal to 4, which is a fairly plane in 3 dimension. So to solve this question, we need to sketch this region, and then we need to determine which integral we will use. Is this region 1, region 2, region 3? And then we have to find the limit of integration. So the first thing I will focus on is sketching this curve here. So this is the z-axis here. This is the y-axis, and the one that going outside from the screen is the x-axis. So I have x, y, z. You can visualize it as you are sitting in a room, or at least try to visualize it in the screen, where x and y, the one pointing up in your screen, y pointing to the right in your screen, and the z-axis is the one that getting out of the screen to your eyes. So that's the idea of how we will graph this one. Of course, this is, as I said, this is, let me just write it down here. This is a paraboloid. And we know how to graph the paraboloid. We will graph the paraboloid in the direction of the variable that is different than the other variable, which is here we have degree 1 in x. So the paraboloid will be in the direction of x. So you can imagine that the paraboloid will come outside the screen to you, toward you. So imagine like paraboloid getting outside the screen, getting to you. So if we graph this one, the one in red here, it will look like this one, and then it would go like this. Like this one. Something like this. This is the paraboloid here. And then x equal to 4, it will be the plane that it will cut this in this direction. So it will be a paraboloid, but it has a cover, and the cover is at x equal to 4. This is just a sketch. We can use GeoGebra to have a better visualization of this region here. Now, we need to find out which variable we want to bound it between two numbers, which variable we will bound it by one variable, and what is the variable that we will bound it by two variables. I think the easiest one, and this is, I would call it trial number 1, and see if we can get what we need, is I need to think about z to be between the two variable x and y. Is something I can do it easily? The answer is yes. Remember, the z is, I'm sorry here, the z is the elevation. So I will bound z between this line here and from bottom by the dotted line. So here is the straight line, and here is the dotted line. And that's how you will bound the z. Now, how do you find this straight line and bottom line? We will go back to this equation. We try to solve it for z. Solve it for z. If we try to solve it for z, this will give me, directly I will write it down here, it will give me this one. The one which is straight line, complete line, will be the positive square root of x over 4 minus y squared, because I will divide everything by 4 and take the y squared to the other side. The dotted one will be the same function, but with the negative sign. So it will be x over 4 minus y squared. And that's how we will bound the z. We get rid of the z. That's the very good news. We find what is z. So that's that's the first thing first. Now, what we need is to do something for the x or the y. The best way to do this next is to consider two-dimension picture between x and y. So try, which means think of the projection on the xy plane. Of course, the projection, one way to look at the projection is forget about the z, imagine z is 0 and see what you will get. So if we imagine z equal to 0, what we will get? We will get this part, and the blue part, which is kind of a parabola, and that's exactly my region. Let's look at it next. If we keep x the same as it is, keep the y, of course the y was only one part, now we need the other part for the y-axis. The parabola will look like this and like this, and here is, this is x equal to 4, and this one here is x equal to 4y squared. Why 4y squared? Because the z, we ignore the z is 0, so we get only x equal 5y squared. And now this is the region I need to bound x on it. So how do we find x is between what and what? That's the big question here. Well, I think for me it's x is clearly, just looking at the picture, we can just take this one here. This is just one of the regions that we need to deal with. This will give me x between two functions. The top is x equal to 4. The bottom is 4y squared. So I finished from the x. That's the good news. The remaining part is to find the bound for the y, and those should be two numbers that y start with. And how we find them? We find the intersection points. So let me go here and find intersection points. How do we find the intersection point? I need to find the x in blue should be equal the x in red. The function in red should equal the function in blue. The function in blue is 4. The function in red is 4y squared. If we cancel the 4, what we get is y squared equal to 1, which means y is plus and negative 1. So the two numbers I'm looking for are negative 1 and 1. And by that, I find the limit of integration, and now it's easy to find the integration. So this is the 2D region as a projection. And now all what we need to do is to write the final answer. Let me do that final answer with a different color. So the integral is, of course, it used to be a double integral of x dv. Now the integral will be 3 integrals from -1 to 1 for the dy. For the x, it will be 4y squared to 4. And for the z, which is the one that is, we need to write it down, it will be negative square root of x over 4 minus y squared to square root of x over 4 minus y squared. One from the negative, one from the positive. And then I do the x and then the z, and then I do the x. Of course, please pause this video. Try to find this integral. Find this integral. Unfortunately, this integral will turn out to be hard to solve. It will not be straightforward. You need so many techniques of integration, moving things here and there. You can do it. Try it. Pause the video. Try it. See how difficult it is. See if you can manage to reach the end. Now, maybe you don't want to go all over those techniques of integration. What will be the second idea? The second idea is we need to change the order of integration. Maybe it will be easy. Why should I start with the z? Maybe I could start with the x or with the y. And that's what I call it. Trial number 1 is I bound the z. So trial number 2, let me now maybe bound something else and see what we would get if we bound something else. So I hope you are ready to bound something else. And for trial 2, I would prefer to maybe I will do the x. The x looks good for me to do it. So let's see if we do trial number 2. Which again, I need to bound the x first. So just let me quickly go back and sketch the region. Just to remind ourselves that this is the region. Look like this. And then, of course, at 4, I need to stop it. Now, if you need to bound the x, of course, the x is this direction, the direction that's coming outside the screen to you. Now, again, the x will be on the red line as a bottom, and it will end up in the blue line. So here, the blue line is 4. The red line, remember, I need to keep it with the z because now I didn't start with the z. So this is what we get with the x. And that's the good news because now we have the function as this. Now, next, take the projection on the YZ plane. So you take this solid here and try to see what will be the image if you smash it to the only YX plane. And that will be exactly, if I'm not mistaken here, this is Z, this is Y. It will be just a circle. The circle, which is 4y squared 4z squared equal to 4. Just a blue circle. That's the projection. Of course, that's not the circle as empty circle. It will be also whatever inside it. So it is the complete circle. That's if we take the projection of this one inside this plane. Of course, this is now very easy to find the bound because if we look here, we can just again do the same thing as we did before. We just can take the one of them, which is, I don't know, maybe the z is between something and the y is between something. Now, if we do the z will be between the positive 1 minus y squared, negative 1 minus y squared. I divide it by 4 and take everything. And the y between negative 1 and 1. So finally, the integration, the triple integral, will be integral from minus 1 to 1 to dy. Integral from negative square root 1 minus y squared to square root 1 minus y squared. And finally, integral on the x from 4 to 4y squared 4z squared x. Now, this is much easier. Just let me write it as a note. Much easier. You can pause this video and try it by using polar coordinates. If you do the polar coordinate, at some point you will need the polar coordinate, because remember I have 1 minus y squared. I have y squared plus z squared. This is a very clear case for the polar coordinate. Use the polar coordinate. You will see that this integral can be evaluated easily. Please write for me in the comment your final answer, and let's compare all the final answer. Thank you for watching this video.